Okay, these are the examples that were left to you. Hopefully you've had a chance to work them out on your own. If not, we're about to get started. When we look at these, we'll notice that we have two logarithmic expressions. We have a log base e and a log base 2. We are going to handle them a little bit differently. Remember that when you're taking the derivative, they both have the same main piece. You're going to take 1 over what you're taking the log of times the derivative of what you're taking the log of. When you have log base e, it's just 1 over what you're taking the log of times the derivative of what you're taking the log of. When you take the derivative of a log base anything other than e, remember you start off with 1 over the natural log of the base you do have times 1 over what you're taking the log of times the derivative of what you're taking the log of. In this case, that would be 8x plus 2. When I go to simplify this, you do want to simplify as much as possible. Notice when I did the 1 over x plus 3 times 1, I do that basically for myself so that I know I've done the derivative of my log correctly. But as a rule, when I simplify, I want to make sure it looks as nice and neat as possible. When I look at what I have left here, you'll notice that the top and this bottom have a factor in common. I can factor out a 2, which will leave me with 4x plus 1. Here I can factor out a 2x, but if I factor out that x, it's not going to cancel with anything in the denominator or in the numerator, so I'm just going to leave it in there. And then I do want to simplify by canceling out those 2's. There's a lot going on here. We have to think about everything. So minus 4x plus 1, all divided by, you can put this behind or you can put it in front. It's just kind of a personal preference. If I put it behind, I'll have to add an extra set of parentheses. I don't really want to do that. So there's my final answer. Let's check example 8. Now example 8's a little more exciting because if we look at what it is, if we leave it in this form, we'll take 1 over what we're taking the log of, which isn't difficult, but then we're going to multiply it by the derivative of what's inside. Look at what is inside. You've got a product rule, you've got a chain rule, and then you've got a quotient rule, all working at the same time. We do not want that. We're going to use our properties to split everything apart. So when I split it apart, the numerator is all multiplied together. I'm going to separate those with addition. The denominator, I'm going to separate that out with subtraction. If it's multiplied on top, it's positive. If it's on the bottom, it's negative. We also have to deal with our powers. When I look at the first term, I have x to the third. X to the third is not difficult to take the derivative of. When I look over here at this one, however, the square root of x, 2x minus 1, that becomes a chain rule. So this one, I would want to take my power down in front. Your square root is a 1/2 power. The others, I would leave them as they are because it's quite easy to take the derivative of your x cubed. So if it involves a chain rule, take that power down. This is the original statement. We have yet to take the derivative. When I go to take the derivative, I'm always going to make sure I denote that with a y prime or a dy over dx or an f of x prime. When I take my derivative, I'm going to have 1 over what I'm taking the log of times the derivative of what I'm taking the log of, plus 1/2, you've got that coefficient, times 1 over what you're taking the log of, times the derivative of what you're taking the log of. And those are in the numerator. I get a little lazy. Minus 1 over what you're taking the log of, times the derivative of what you're taking the log of. Now we can simplify. You've got an x squared on top and x to the third on the bottom, so those are going to cancel out. That's going to leave you with a 1 power. That simplifies to 3 over x. The next term, those 2's are going to cancel each other out, which makes it look a little nicer. We have 1 over 2x minus 1. Our last term, nothing cancels, but we can make it look just a little bit smaller. Here we are. Now when I look at 8, I notice that I have the natural log, or any log base will work. If I have a product rule, a quotient rule, a chain rule all involved, I am going to want to use properties of logs to simplify. Now just to give you a sneak peek into what we're doing tomorrow, what is going to happen when we have no logs, not a log in sight, but we have product rules, chain rules, quotient rules? I wonder how we're going to use logs to help us out. So tune in tomorrow in class when we figure out what can we do with something that, ooh, we wish we had logs, but we don't. So tune